right, solving a word problem on a unit rate. What these are going to use is what happens here. I'm not even going to show that formula. I don't think I need to. So miles per hour. When you have miles per hour, the word per in math means divide. Okay. So you can just put miles over hours and it should always work out. So you do miles, 240 miles over 4 hours. By the way, when you do math, you actually do the units as well. So this is why you do miles divided by hours, which come miles per hour. So this is, you are traveling at 60 miles an hour. So that is 60 miles an hour. And then it says use that to calculate how far you go in 7 hours. Not going to go too far into this because we'll see how far we do it. This is something you use a lot in like chemistry. But 60 miles an hour is called dimensional analysis. If you do get stuck of whether you should multiply or divide, you can do this. So in 7 hours, I want the hours to cancel out. So I write hours on top so that when I go to do this, the hours cancel out. And I'm going to be left with miles, and 60 times 7 would be 420. So this tells you whether to multiply or divide. If it was a divide, my hours would be down here. But I want to put it up here because I want my hours to cancel out. I want an hour on top and an hour on bottom. So that does kind of help you. We'll see this one, what it does. I'm just curious. 3 cups of flour for 12 servings. Find the unit rate. We have cups per serving. Okay. So it is nice to write that. So we have 3 cups and 12 servings. So this is 0.25 cups per serving. Cups per serving. So if I had 0.25 cups per serving, which is 1/4, and I want to know we have 20 servings. Well, I'm going to write 20 servings up here so that when I do this problem, the servings cancel out. So since they are both on top, I multiply them. And this would be 5 cups for 20 servings. So that little like box or that little rectangle thing right here, it's called dimensional analysis, but really just helps you remember whether to multiply or divide. You don't have to do that anyway if you think you can do it without it. All right, cross multiplying, solving a proportion. Sorry, it started me off with a harder one here. I thought maybe there'd be an easy one. X plus 2 over 3 equals 5 over 6. So proportions is the main part of this application assignment. But what you have to do is cross multiply. Cross multiply means you take the top one of the left and the bottom one times the right. So this would be 6 times x plus 2. Or you can go ahead and distribute it out and it would be 6x plus 12. And then you do the opposite. Bottom left times top right. So 3 times 5 would be 15. Okay. So that is what cross multiplying means. That is the way you solve when 2 proportions are equal to each other. Now you solve for x. So I subtract 12 from both sides and divide by 6, not 3. Divide by 6, so x is equal to 0.5. And you can always take that and plug it back in to check your answer. So the hard part about proportions, most of y'all have seen cross multiplying before, is setting them up. And this is where you use the words. If 2 gallons of paint cover 800 square feet, how many gallons of paint are needed to cover 1,200 square feet? So write it out to where you say, okay, I'm going to do gallons over square feet. So I put 2 gallons to 800 square feet. Actually, I want that to be black. 2 gallons to 800 square feet. How many gallons are needed is my x over 1,200 square feet. Okay. Now what happens here is there should always be a connection to these. These are my gallons, right? Because gallons are on top, and these are my square feet. Square feet are on the bottom. So there should be a connection this way, left and right. But there should also be a connection this way. And that's how you know you did it right. I know that 2 gallons covers 800. I don't know how many gallons coverage needed to 1,200. Okay, so now cross multiply. 2 times 1,200 would be 2,400. And then 800 times X. And then we just divide by 800. So it's 3 gallons would cover 2,400. And always take 2 seconds. I hesitated there because I thought it was backwards. 2 gallons covers 800, so you need more gallons than that to cover 1,200, right? So always take 2 seconds to make sure your answer makes sense. Like I need more gallons than 2 because I'm covering more square feet. But you always have to make sure that there is a connection on your proportion when you set it up. All right, similar polygons. This one does give some people trouble, but I will try to make it as easy as possible for you. Okay, similar polygons. What you have to do is match the sides up. So what I mean by that, the first thing you want to identify is what is your X, okay? What'd you say? Sorry. The first thing you have to do is identify your X. So my X is right there. That matches up with this side over here. Right? Those are the same. Like the top side of the right one is going to be similar to the top side of the left one. So I'm going to put X over 4. You can do 4 over X. It doesn't matter. I'll talk about that in just a second. So now on the other one, I'm going to use this side and this side. So I'm going to use the right side of both of them. Now here's where you got to be careful. This is where you have to match everything up with. X is my top of the right side, right? So what I need to do is make sure I put the right triangle on this one and then the left one on this one. So let's go back over this real quick. I know that these have something in common because they are both the tops of the triangle, right? And I know that these have something in common because they're both the right of the triangle, okay? But also, these have something in common. They are both the right triangle. The triangle on the right. It's not even a triangle, is it? I keep saying triangle. That means it's time to stop. The polygon on the right. Okay, those are the polygon on the right. And the bottom ones deal with my polygon on the left. So there's always a correspondence with the tops and the bottoms, but then there's also a correspondence with this and this. So how you set these up could be different. Let's solve this real quick, and I will go over. I might do another one just to show you. All right. X times 5 would be 5x. And then 4 times 4 would be 16. So divide by 5, and x is 16 over 5, which probably keep it as a fraction. That's like 3.2, but probably keep it as a fraction. Okay.
Just on the test, I was having a hard time putting equals in. Like it would be like x equals 7. And
well, like this box.
There's no way I could put the equals sign.
I know this. Well, like this box right here already has x equal, so you just put 7. Okay. If it already has like x equal, then you don't need to.
So if it just says find the answer, because it wasn't saying solve for x, then I just go ahead and put the answer. I don't worry about the x. So
right. So like here's a harder looking one. We'll do it real quick. Okay, so find your x. My x is the bottom. Okay, I'm going to set this one up differently. Let's do x on top, and then I want to use, they're all decimals. That's fine, though. X and 4.8. It does not matter what numbers you choose to use. You just have to, in the other proportion, you have to use the ones that match. So in this proportion on the left, I used the numbers on the right? These are both red. So now what I have to do is match this up. So my number on top is the bottom. So I'm going to use the number on the bottom over here. And then I use the number on the right for this one. Does that make sense? So it doesn't matter how you set it up. I set it up a little bit differently last time, but they has to correspond. This is the polygon on the right. This is the polygon on the left. Now these right here are the numbers on the bottom right here. And then these right here are the numbers on the right. So they have to correspond like that. And then to solve this real quick, that's x times 3, which is 3x. And this one is 4.8 times 5, which would be 24. I don't know. All right, only a couple more and then we're done. Okay, this is converting between Fahrenheit and Celsius. So if I'm doing 68 degrees Fahrenheit and I want to go to Celsius, I would use this formula right here. So we would do 5/9 times 68 minus 32. That would be 36 times 5/9. Most of these I think you can do without a calculator, but you may have to. So this would be like 36 divided by 9 would be 4. 4 times 5 would be 20. If you have to use a calculator, just do it. 5 times 36 divided by 9. You multiply the tops and you divide the bottom. If you're going the other way, I think they always give you this, so it's not hard. You do it a little bit differently because you don't have inside the parentheses. So when we plug this one in, we do 9/5 times 25 plus 32. So on this one, you do 25 divided by 5 is 5. 5 times 9 would be 45, and then you add the 32. Okay? If you're doing that in a calculator, you do 9 times 25 divided by 5, and you get your answer. This actually goes back to the dimensional analysis problems. If we're going 5 feet to inches, they will give you this information. But if I go 5 feet to inches, I know that there's 12 inches in 1 foot, right? So 12 inches in 1 foot. I write it like this because I want the feet to cancel out. And that tells me I multiply to get inches. So if you need to write it like this to help you work these out, that is fine. We haven't had a divide one, have we? Let's change this problem and get some divide. Oh, look. Apple will just do it right there for me. Let's do 32 quarts, 2 gallons. So on this one, I have 32 quarts, and I'm trying to go 2 gallons. It gives me the 1 gallon to 4 quarts right there. So what I want to do on this one is I want to write quarts on the bottom, and there's 4 quarts for every gallon. Why am I writing quarts on the bottom? So that when I do it, quarts on top, quarts on the bottom cancel out. And now my number, what you actually do is multiply everything on top and divide by on the bottom. So 32 divided by 4 would be 8. That is why this little rectangle thing, dimensional analysis, does help you. Because if you put the number on top, you multiply. If you put the number on bottom, you divide. And you put it on bottom because I want quarts to cancel out. Easiest way to convert with metric is King Henry died drinking chocolate milk. Okay, so king, kilo, hecta, deca, and the base. What I mean by base is you could do this for meters, which is length. You could do it for grams, which is weight, and you could do it for liters, which is like volume. So you could do that for either one of those. And then you get smaller, deci, centi, and milli. So these are prefixes. So decimeter, deciliter, centigrams, centiliters, centimeters, millimeters, milligrams, milliliters, okay? And these are actually super easy to do because you have, on this one right here, we have 7 kilometers, and we're trying to go 2 meters, right? So I'm going to go from there to there, I have to move 1, 2, 3 spots to the right. So what I do is I take the decimal and I move it 1, 2, 3 spots to the right. So 7 kilometers is the same thing as 7,000 meters. They're going to, in the explanation, they're going to talk about like multiplying by 1,000 and different things like that. But this is definitely the easiest way to do it. You just move the decimal, how many ever spots you have to do it for this. So like on this one, no. I have 250 centimeters, so that goes under here. 250 centimeters, and I'm trying to go to meters. 1, 2. 1, 2. Okay? So if my decimal is normally right here at the end, I move it 1, 2 to the left. 2 to the left. Okay? So my answer would be 2.5 meters. So you put where you start, you put where you finish, and you just count. If I go 4 to the left, then I move my decimal 4 to the left. I know I'm going fast here at the end, but I know you all got to be checked out. I've been going for a long time today. Here, 10 kilometers to miles. They tell us right there what our conversion is. For 1 kilometer is 0.621 miles. So on this one, the kilometers cancel out, and I'm left with miles. So it'd be 6.21. So that's kind of the same as what we were doing before. If we need to go back over any of these Wednesday, we can. Last problem, another word problem of proportions. A recipe for 4 people requires 2 cups of sugar. How many cups, that's going to be down here, are required for 10 people? So again, you got to set it up to where it all matches. So now I do 4 times x and 2 times 10, divide by 4, and x equals 5. So it's okay to write the labels on there to make sure that they match. I have the people on top, I have the cups on bottom, and then also I know that this recipe goes with this one. 4 people, 2 cups, and then 10 people, how many cups? So they always match up like that.